as you can see that we want to do end-to-end RAG, but which is for the production. So one of the main use cases for the production is that whenever a future documents come or previous documents get updated, you don't need to do anything manually. The entire system should run end to end automatically in the production itself without any changes, and all the changes which is made to the document should be reflected in the real time at the output. So the first thing as part of this we do in Azure is whenever you have an input document, you need to keep the document in some kind of storage in Azure. Either it can be MongoDB or Azure Blob or Azure SQL database itself. But for the example, I'm currently using MongoDB to save the documents. So imagine that if your document is like a really big thing, let's assume that your document is in the form of a JSON structure like a question and answer. Question might be capital of Paris, capital of France, and answer can be Paris. And all such documents, whichever you have, will be stored in Mongo database. And once it is stored in the Mongo database, the next step is that what you wanted to do with such kind of documents. As you know, there are like two popular things which people do these days. One is like if the document is pretty big, you can actually chunk into smaller documents. And the next thing you ideally do is basically have a text embedding which converts the input text to vectors as a output. So as this is a production thing and in Azure, we want all of those things to be done automatically without any interference from our end. And to do that, we actually deploy a custom embedding model, which is a sentence transformers model and sentence transformers. And this will be hosted in a function app which is completely free. And for this entire tutorial to run end to end, you don't need to pay for any of the resources. We'll be using almost all the resources which are free end to end. And as you can see that we'll host a function app, and inside that function app it will have a embedding model where a simple API call where you give input text and output it will give you the embedding, and all of them will be stored in the Azure search index once it finishes. And the way we do is that in Azure is document cracking is nothing but converting a bigger document into smaller chunks, and these downfields are just an explanation of the above diagram like inbuilt. And field mappings are basically whenever you have an input question and answer, and if you want to map it to like a different fields other than question and answer, you can still do that. And the skill execution, skill is nothing but the custom embedding model which we built. A skill can be anything. In our case, the skill is as simple as converting text to vector. And output mapping is the mappings which are present in the index, as the search index also does have a certain kind of names which we will see, and we will see what are the names we need to do that. Once we do that, we'll have a RAG end to end, and whenever you upload a new documents again, the MongoDB into the MongoDB, the skill which we developed will automatically search for any changes in the Mongo database, and it will then convert the input text into embeddings and keep it in the search index for us to search. So at the final, whenever you ask an input query, it will come here, and once it comes here, input query, it gets the top K documents, and from there we can do give it to any kind of open source model to answer top K input query and the relevant documentation chunks to answer the question. And we'll be using semantic search to basically pull the top K documents. The semantic search, even though sounds complex, is just an addition of textual search plus vector search. And that's the reason Azure AI search is far more uh, really sophisticated when compared to any other textual searches or cognitive just a vector searches. And there have been like benchmarks which actually showed that it can outperform any kind of a textual search or a vector search itself. And let's try to get this done end to end. And as part of the step one, we'll be doing creation of MongoDB and inserting documents into it. As part of the step two, we'll be creating a small skill which basically takes a input and outputs a textual vector for the input. And step three would be creation of a Azure search index
As
and
part of
basically
building a
mapping from
production
input to
ready
output.
rack, the first part of the series, we wanted to create a Cosmos DB, which is kind of a MongoDB, and basically upload some data to it. So at the end of the series, whenever you upload a new data to this Cosmos DB, the entire pipeline will get triggered automatically, and you don't need to change anything for your documents to get reflected in your rag. So imagine that you kept a new document about your maybe current pay, and whenever you search in the rag, it will actually show without doing any changes in the middle. So that's why it's like a production ready rag. So you don't need to do anything from your end to end once this all part series is done. So the parts consist of like majorly like three parts. One is basically uh, creating a Cosmos DB and uploading a data to it. And the second part is creating a custom function app. And basically, the app, whenever you input some text, it should output the embedding of the input. And final thing is Azure AI search, which basically takes this input data and triggers this custom function app to to basically take convert the input data into vectors and store inside the search index itself. So let's get started with the Cosmos DB first. I'm using a free tier Cosmos DB, and you should click Azure Cosmos DB for MongoDB. And I think we can create a weak core cluster. Let's give the name as Azure RAG and click on Azure free tier. Otherwise, it would be a lot for us, like the cost. Let's give the name as Azure RAG and give password as something. And I don't think it will take an easy password, but yeah, give some password. Please do remember the username, especially because you can always reset the password. And let's see, networking. And we don't need to have a tags and other stuff, so let's create this one. It will take some time for actually to create finishing this cluster and itself, because whenever you have in a free type version, it usually takes more time. I did observe that. Deployment is finished. Now let's go to resource. And the one thing we need from here is that go to settings, and there will be a thing called connection strings, and we do need it for this one. And you need to change the username and password with the username and password which you just created. And let's go to some of the code on how we can actually upload these documents to the MongoDB itself. So I do created a sample data which is like in the format of ID question and answer, which is a small data, but we can definitely upload more data once we finish the pipeline end to end. And you need to install PyMongo for uploading the documents uh, from local to the Mongo database itself. And we need to copy paste our string here. Okay. And do change it with the username and password which you just created. And now you can list the databases and see the collection pairs which we created too. Yeah. As part of the next step, we'll be creating a function app which can actually take input of a text and output the vector itself. And we'll be seeing how we can actually integrate that function app into our Azure AI search, which is the main component of our whole series.